Hello. Hi guys. Yeah, so today I just wanted to show you something absolutely crazy about Facebook's login mechanism. Okay, let's just check this out. I made a fake account for illustrative purposes today. So basically I made this Timmy account. We're just going to go ahead and log back out. And we're going to be using developer tools again today. So before you log in, once you're on the login page, you want to open up the developer tools and you're going to want to go to the network tab. So I made this fake Timmy account here. Here we go, sorry about that. And I'm going to go ahead and click log in. So we'll see all the network traffic here that's happening on the Facebook website, and we can clearly see here that some of the network traffic is login attempt. So if you know a little bit about web development, you know that the password is probably going to be located in the post message. And here we go, sure enough, the password is in plain text here. So the password is TimmyIsGoat 69 ! The $21 is, I believe, some kind of code to signify the exclamation mark. Yes, the ASCII code for exclamation mark is in fact 21, so that's what they're doing here. So it's TimmyIsGoat 21. So the question is what should be happening instead of this incredibly unsecure, frankly. Let's think about it from a bad person's point of view. We install some kind of malware via USB or download from the person who willingly clicked yes on something they weren't entirely sure about. It is some kind of snooper that listens for browser traffic, and when you log into Facebook, it knows that it's this network, it knows that it's in the request body, and the password's here in plain text. So, I mean, that's potentially dangerous. So the next question is what should be happening? I'm going to go ahead and log in on Pinterest doing the same-ish kind of thing with developer tools open, and I'll show you how we get blocked. Gotta go ahead and log out here. The password won't be in raw string. So we're going to open up developer tools again, and this time we are sticking on the network page once again, and now we're going to go TimmyIsGoat. Now we're going to log in. So now when we log in, we're going to see all the network traffic happening when we log in. And we'll see here up at the start, it's going to be one of the first few, obviously, because before it does anything else on the page, it needs to make sure that we are, in fact, Timmy Tonga before we see Timmy Tonga's view here on Pinterest. So it's likely from the Facebook experiment we saw that it was a HTTP post message. So we're going to be looking here, and we see in the body, in the request body, there's just this data with all of this garbly goop. Even if we copy it, put it up in a notepad, it's still really just garbly goop. There's not much here for us. So not really sure. We see a couple other posts here. It's the same thing. Here's a post. Oh, we're looking maybe like there's something here, but there's not. This is all just stuff that's keeping the website working, a whole bunch of stuff in the back end. I scoured this and I could not find the password anywhere, and that's because it's likely happening in one of these here. So you see this handshake session. This is proper communication of websites, and it's much more safer than obviously having your password in raw string. I just wanted to point that out. I do believe the reason for this is because Facebook was programmed before a lot of modern policies and such in industry, and at this point, it's impossible to go back and change such a large website. So I'm not bashing on Facebook. I just wanted to show something interesting about the internet and about how logins work, and sometimes the sense that you are secure is false.